Welcome to Nature of Conservation. I'm Judith Richmond, your host. And in thinking about the severe weather that we've had lately, I thought, it'd be helpful to invite someone to our show that could help us understand what's going on, not just locally, but worldwide. So I've invited Bill Runyan, a friend and Sierra Club activist who's been really following the weather and climate changes for a long time, to our show to help us understand what's going on worldwide. Welcome to the show, Bill. Glad you're here.
I'm glad to be here.
Well, let's cut through the chase here. I mean, because it is out there that there's severe weather going on. Mm-hmm. People are experiencing it all over the world, and so it's not just isolated to us here. So, what is the scientific word on what's causing, and how is all this all interrelated? These extreme weather changes we've seen.
Well, it's all part of climate change, and climate change in turn is caused by global warming. The temperature of the Earth on average has gone up about 1 degree Fahrenheit in the last 30 years, and that increase is going to continue.
So with this, so it's going, and so why is it going up?
Well,
in other words, 1 degree Fahrenheit may not sound like much, but on a global average,
yes,
it can be quite a bit. That means averaging winter, summer, the whole 24-hour days, 365-day year. Okay.
Everything. And
yes,
the thing to remember is that it is an average. Mm-hmm. And weather is not climate, even though an increase of 1 degree leads to more extremes than our weather. Our climate rather is weather averaged over a 30-year period.
So if somebody said, well, we can't have global warming because it was so cold last night, I froze to death. That's 1 day, one person, that's not climate.
Yeah, these extremes will continue even if it got considerably warmer. You'd still have record colds. You'll have a lot more record highs.
So physically, what's going on to make the Earth get warmer?
Well, when sunlight reaches the Earth in the visible and ultraviolet range, it's re-radiated back into space. After it's radiated to the Earth, it's radiated back into space. But before it can get to the space, it has to go through our atmosphere. And when it hits greenhouse gases like CO2, water vapor, nitrous oxide, methane, that radiates it back to the Earth in infrared, as it's radiated from the Earth in infrared back to the Earth in infrared, and that's heat. And so the troposphere is warming. That's the lower atmosphere is warming, even though the stratosphere is not, because it's just like a big blanket that it's
so it's that whole greenhouse effect. I mean, I remember when I was a kid in grammar school, you studied that because of greenhouse gases, that kept our planet from being cold like the other planets. We've got these greenhouse gases. Was that kind of what it was?
Yeah.
But now we've got too many
much
greenhouse gases.
Well, yes. CO2 is the main one. And pre-Revolutionary War levels were about, say, 280 parts per million.
Okay, got it.
And 70s, say, it was a little less than 340 parts per million. And now it's a little over 390 parts per million.
And so because we're producing more carbon dioxide, more of these fossil fuels are being burned,
exactly,
we're going to have more, and it's going to do nothing but get
hotter. Because
it's all, that atmosphere is loaded up with the fossil fuel emissions.
Exactly.
So we're seeing, so the effect of all this is that, like, let's say drought. Gosh, no, that's one of the more obvious extreme weather things we've seen.
Yeah, well, I think more obviously would be heat, and as warmer as heat, and heat stress has decreased their potential yields in corn and wheat.
Because these plants are trying to, they've been hybridized to grow at a certain temperature range.
Yeah.
And so now it's getting hotter, so the plants are being stressed by too much heat. So not.
Yeah.
So plants have to have a certain heat range in addition to a certain amount of water.
Right, exactly. Which does bring me to drought, and because the hotter it gets, the more evaporation you're going to have.
Which is going to be
cause more drought.
More drought.
Yeah, or just a general decrease in rainfall in certain places. This is the odd thing about climate change. As more evaporation occurs, you're going to get more precipitation.
Oh, because the moisture is taken from the surface area of the land up into the clouds. Okay.
Right,
so
and it has to come back down. What goes up must come back down. But it is not necessarily coming down in the same places where it came up from. So the dry areas are getting drier, wet areas are getting wetter, and there's a general change in weather patterns, and the fact we're having more storms, and they're more frequent and they're more intense.
And they're more intense, more frequent because there's more moisture being taken from the earth?
Exactly. And there's more water vapor in the air in which to form rain. But getting back to the droughts, it's been bad year for droughts, actually several years. Our Southwest is having experienced horrible droughts. Horn of Africa is experiencing the worst drought it's had in 60 years. Russia had a horrible drought last year, and Australia is having, or had a horrible drought.
Oh gosh, but it was followed by the terrible flood, wasn't it?
Yeah, that's when the part where it comes back down again.
Okay, so it's the heat is drawing up all this moisture out of the land, and then you're going to have it dumped.
Yeah, somewhere.
Yeah.
In Australia, is recently, Brisbane area, Queensland, of course, closer to home, Nashville. Nashville was flooded.
So flooding, I mean, the flooding has been a huge phenomenon all over the world. I mean, right here in Memphis, Tennessee, the Mississippi River with the record floods we had there. So, so exactly. That flooding is a result of
more water.
More water
coming down as rain.
Okay.
Which is consistent with
and then the snow melts. That would also affect the amount of flooding.
Yes, there's more heat to melt the snow, so we're getting more rapid melting, which is a problem in itself.
Okay, so the snow melt didn't occur over a gradual period of time.
Yeah, it used to be a gradual period of time, and now it's, since we're getting earlier springs, I think they're averaging like 10 days earlier than they did, historically. Well,
I just recently got back from Germany, and I was in the Black Forest and these farming communities, and they said that they were harvesting hay 4 weeks earlier than they ever harvested. I mean, spring is coming earlier, summer's coming earlier, so it's a worldwide thing, I think.
Yeah.
But with the snow melt, we have more snow these days.
Yeah, we have more snow because there's more precipitation from the air. But the important thing to remember is warmer air holds more moisture.
Warmer air, because the molecules are further apart and they can hold more. Okay, right.
But as long as it's below freezing, it's going to come down as snow and not as rain. So you're still going to get like these big snowstorms. So people say, oh, there's no global warming because of big snowstorms. No, we have big snowstorms because of global warming, not despite it. Because
it's picking up more moisture and it's keeping that temperature just low enough to make the snow. And
yeah, so you get these record snowstorms. Those are likely to continue until it gets too warm, then it'll be rainstorms.
So with these record snowstorms, that's going to definitely contribute to accumulated snow, which is going to cause
the flooding when it melts.
The flooding.
Yeah.
And then this flooding, I mean, the rain, like you say, it's deposited at different places. The wet places are getting wetter, dry places are getting drier. So, I mean, it seems like we're going to need to come up with some way to store all this water that's being dumped at X and Y needs it over here.
Yeah.
Because rivers like the Colorado River, I mean,
a lot of reservoirs can't hold it all. They're supposed to like deliver a certain amount of water certain periods of time, but they're getting more water than they can handle, and then they don't have enough afterwards because it just melts.
So
or rather snow melting.
This drought thing is pretty frightening because all these forest fires we've had.
Yes, when you get drought, that weakens trees, and weakened trees are more susceptible to pests, and they die. Mm-hmm. And then dead trees or even dying trees are more susceptible to wildfires.
And the lightning strikes are up too. I mean, I've seen that. I mean, just our storms around here, they're more violent with more lightning.
Right, we're having more storms and more lightning. There's a study in a scientific institute in Brazil said that for every degree of global warming, there'll be a 10% increase in lightning strikes. So that's pretty scary in and of itself. So we have more people killed by lightning.
And more trees hit by lightning and more forest fires.
Exactly.
So, but then when the forest, I remember reading this because I'm reading about the rainforest, using the burning of the rainforest to create more cropland. Mm-hmm. And they say that the burning of the rainforest, of course, puts more CO2 into the atmosphere because it's converting that tree back to
CO2, which of course will increase the global warming further.
I mean, I've read that the burning of those rainforests in the Amazon are affecting our climate patterns up here.
Yeah.
I mean, I think the thing about all this that's so serious is that what happens in Brazil affects what happens here, and what happens, the flooding out here, it can affect people in other areas, and it's just, I mean, we're in a terrible feedback loop.
Yeah,
I think
it's all connected. In the Arctic, it's losing more ice every summer. I think 40% is the last figure I saw, and people usually think
40% of their ice cap.
Yeah,
oh my God.
40% more than it used to is melting in the summer. It's not gone yet. But
right.
And that's rough on polar bears and also just the natives, like in Greenland. Mm-hmm. They used to hunt with dog sleds. And they have these dogs. Now they have a lot of unemployed sled dogs because there's not enough ice. They're having to use boats. And like Greenland in 2010 saw its highest ever melting of its ice.
No.
Yeah.
Well, I know, thinking about doing this show, I looked at those pictures from space that the astronauts took of Earth, and of course what they do now with the satellites. I mean, that polar ice cap at the Arctic Circle was so much more pronounced in the 70s, and now you can see all that blue water rather than the ice, and it's frightening because
it's another feedback loop.
Okay, how's that a feedback loop?
Well, there's more blue water, and it's not reflecting the sun's rays like the ice does, and so it's absorbing more heat, which will melt more ice.
So it just keeps, all right, so it's going to melt faster.
Yeah, it'll melt the permafrost. Well, permafrost is already melting. They're having problems.
That's on the land. The permafrost.
Yeah, the permafrost is on the land. Sorry, it's permanently frozen soil. That's
soil. Okay. Yeah.
Right. And roads and railroads and buildings are beginning to fall in. Oil pipelines.
Because it's smushy. It's like
smushy. Yeah.
Okay.
And that's a problem. But that brings up another feedback loop because as the soil melts, so to speak, because you can talk about soil melting.
Right.
Ice in it.
Thaws.
That'd be the word. Bacteria that were inactive and now become active, and they start rotting the vegetative matter, and the process produce methane. And the methane is a much more potent greenhouse gas than CO2.
Oh, yes.
Yeah. I even saw a special where they were watching it come out of permafrost, and they're sitting on fire.
What now?
They were just places where permafrost was thawing, and they could light it, and they could light the methane.
Was that much methane gas being?
Yeah, they could light the methane.